Another thing we have to worry about when we have pointers to objects, especially class objects, is the problem of a dangling pointer. So let me illustrate that. So let me copy pointer 3b to pointer 4.cc. And what I'm going to do here is I'm going to allocate space for a new point object. But then here I'm going to intentionally set it to null. And you know what this has the effect of doing is it just represents the fact that the pointer does not point to the object that I think it should. I'm kind of simulating that scenario. Now there are two problems here. So first of all, by redirecting this pointer, by making it point to null, I'm no longer going to be able to refer to or get access to this dynamically allocated point object. But more problematic is when I try to call this print method, there is no object the pointer points to. So what's going to happen is this is going to be a core dump. And I'll show you what that is. That is going to make the program stop, and it will do something called dump core, and then I will show you how we can use a debugger to figure out where this happened. So first of all, let's run this program, compile it, and run it. And you'll see that the program stopped. I get what's called a segmentation fault. I get what's called a core dump. And in my directory, I have this new file called a core file. And this is a snapshot of memory, the program's memory when it stopped. And I can use a debugger to analyze that file, and it can tell me where the problem, where the program terminated, and that will give me some insight into what caused the problem. First thing I have to do is I have to make sure to compile my program with the -G option, which generates the symbolic debugging information. I'm going to go ahead and remove the core file, and I'm going to run it. And so now I get the same segmentation fault, and I can use GDB, which is the GNU debugger, and I'm going to give it my executable and the core file. Now this is going to tell me exactly where my program terminated. It terminated in the file pointer 4.cc on line 23, and it tells me that it tried to print an object, but it couldn't. So if I do a backtrace, it shows me the call stack, and you can see that at main on line 31, I tried to call the print method. So that'll give me at least an indication where I can go look. So if I look at pointer 4.cc and I look on line 31, you can see that this is where I tried to call this. And if you look again at the output, this first argument, this pointer, is showing that it's passing in null as an argument. And what this means is that there is no object associated with the pointer, and that's why this program is crashing when it tries to call the print method. For this print method, there is no point object, and that's why our program crashed. So this notion of a pointer, of course, you, the programmer, thinks the point. You think that the pointer points to something, but in reality, it's not pointing to something. And this is what's going to cause this core dump. So that's the issue of a dangling pointer. And of course, in this simple case, this case where we're just illustrating, all I have to do is make sure that my pointer is actually pointing to an object. But in a complicated program, you're going to be manipulating pointers at some point during execution. a pointer will not be pointing to what you think it's pointing to or should be pointing to, and you'll get a cordon, and you'll have to go in there and find out, well, which of these pointers got misdirected. So now if I compile this and I run it again, you see that it has proper execution. So a dangling pointer is just where you have a pointer, it should be pointing to something, but it's actually not. And when you try to call a method on a dangling pointer, you're going to get a cordon.